What's up, skeptics? Welcome to another episode of Reason to Doubt, your source for all things skeptical. I am Jordan, and today I am joined right now by Zach. Hopefully, John will be showing up at some point. But today we're going to be talking about how to do your own research. Some people in the comments have been asking me, like, when I prepare these videos and look into stuff, how do I do that? How do I know what's good? And I thought, who better to talk about it than two people with PhDs who's like, that's their entire job, right? So, Dr. Zach, if people aren't familiar with your channel, why don't you go ahead and introduce yourself? Tell us where they can find you and what you've got coming up.
Yeah. So I'm Zach. I'm an evolutionary biologist. I specialize in population genetics. I run a YouTube channel at Talk PopGen where I do like a little mix of evolution education. I do some pseudoscience debunking as well, and a lot of like history and philosophy of science. Some things that I've got coming up is maybe a controversial one for amongst the science friends, and that I'm doing a video on why species are real. And that's something that I hope will really raise the hackles of a lot of my science friends. But
if anything is going to get you excommunicated from the friend group, it is that.
Yeah. So
you could we have like a group chat with the science friends that we're in, and when Zach was like, "Hey, I think I might make a video as like that species are real," you could just feel like the the anger.
Yeah. So I think it'll be fun. It'll be playful, and I think it'll be hopefully sort of thought provoking.
That's cool. So I don't know if he's going to join us. We also invited John, who's Age of Rocks. If he comes in, he can introduce himself then. But we're just going to go ahead and dive right in. So what we're talking about today is how to do your own research. Now, we often hear this phrase, and I kind of make fun of it sometimes. The do your own research is like the rallying cry of the ignorant, you know?
Like because on your toilet with your phone.
Yeah, because when they mean do your own research, they just, mean go look at whatever news outlet they prefer, their propaganda of choice, and spit that back with no criticism. But you should be able to do your own research in that you should be able to look into questions that you have and try to find good information. Part of good skepticism is recognizing that you're not an expert in possibly anything, but definitely not everything. And so the reason we have experts is so they can give us answers. But today we were talking before the show started about how in the past it was hard to get information, but by the nature of the places you had to get it, go to a library or something, you could be better assured that you were getting good stuff. Now we have like the opposite problem where there's just information everywhere, and a lot of it is bogus. So if you're trying to figure out the answer to a question, it can be hard to know even where to start.
Yeah.
So when you're looking into a question, maybe something that's outside your field you're not super familiar in, what's like the first step? How do you prepare yourself?
Yeah, that's a really great question. And it is, I think, an important framing, and that when you're sort of in the field, it's very easy to know what's good and what's bad. You know where to look, you know what journals to expect. But there's been plenty of instances when I've had to go into other fields. I did some work in biogeography. And for those that don't know, biogeography is the study of like why animals live where they do and how they got there, their distributions. And since my background is mostly population genetics, this also includes some geology. So I had to like go into the geological literature, and I don't know anything about geology or like what's a good geology journal, or like I didn't know anything about that. So I had to like really think about, okay, how do I know what's a legitimate journal? And so one of the first things that I did is just look up the most prestigious geology journals, right? So if you just think about Googling prestigious science journals, you will get a list of journals. They will name like the sort of the top ones. And this is, I think, a sort of safe place to begin. It like gives you sort of a list of potential things that you can then start narrowing down further. So sort of the big ones that will always come up are things like Science, Nature, Cell, right? These are like your really big, highly internationally respected journals.
So I'm hearing is one word. If it has a one-word name, it's good to go.
So I don't. Surprisingly, that seems to be at least a good start. Nature and Science are like the two most respected science journals in the world. And so yeah, so I think that's probably a good place to sort of get started, at least thinking about finding a respectable journal.
So just in case someone isn't familiar, when we say a journal, we're talking about peer-reviewed research. What does it mean for something to be peer-reviewed? What sort of steps do you have to go through?
Yeah, so peer review is a really fascinating process, and it's done a little bit differently depending on the journal itself. A lot of journals are run by academic societies, which maybe we can talk about a little bit. But in effect, they each sort of have their own peer review process. But the basics is it works like this: you find a handling editor, an associate editor that's in the topic that your paper specializes in, right? So first, you want to find the expert editor for that journal that has the expertise of the paper that you're going to submit. Now, they are not the peer reviewer, they are the handling person. So they're going to take it and they know who to then contact. You can recommend some people that you think are additional experts that would be good reviewers. There's a rule of thumb: you never recommend anyone you've worked with in the past. You don't recommend your buddies, right? You don't recommend people you know personally. There's very strict rules about who you can recommend as reviewers. But then the editor ultimately has the decision of who they pick as their reviewers. And since they're experts of the topic, they pick other experts. You don't know who they are. It's sort of a blind process. You don't know them and they don't know you. Your name, affiliations and stuff are typically removed from the paper so that it's a double blind process. And then what the reviewers will do is they will read it. They will provide just sort of like initial feedback. Sometimes they will, like, you're even required for them to go in and run your computer code. Like if you have software code, if you do stats, then they're supposed to go in, make sure your stats are good, that sort of thing, right? And so then they basically write up their recommendation, which could be almost inevitably it's major revision. That you can almost guarantee your first response is going to be, we want big changes, right? I don't think I've ever had a paper that was like, good to go. It's never like that. They always have problems, and it's a back and forth. And it can take anywhere from a few months to up to a year or more before that paper finally is in a form where all the reviewers, of which there can be many, right? So you might have 3 or 4 the first round. You can have 3 or 4 new ones the second round. Every round you go through, you're getting new people looking at it. And then once you've appeased all of them and the editor sort of signs off, then it finally can get published. So that's in a nutshell what the peer review process is like.
So when a peer reviewer signs off on it and gives their stamp of approval, does that mean I agree with everything this paper says and I agree it is correct and should be taken out into the world?
Oh, that's a good point. Not necessarily. What they agree with is typically that the study was well designed to address the question that was proposed. Now, that doesn't mean that they necessarily agree with everything, and they often don't. What it means is that we will let you put this out into the world. We at least give our stamp that the stats were well done, the study was well designed, etc. But it will be up to the rest of the scientific community to then respond to it, right? So yeah, it's basically a stamp of approval that at least in this setting, the science was well done, and we will let you propose it to the rest of the world.
So it's sort of like a quality check. The things you said your research was about, your experiment was about, they match the things you did. Your math is not fundamentally flawed, that kind of stuff.
Exactly. Yeah. There's no there's no fundamental failings in logic. The stats were used correctly, right? Like those sorts of things. Because yes, so often, scientists disagree, especially if you're publishing a new paper, you're often presenting new things. And these reviewers are the first people outside of your lab to see these new ideas, right? And so, there are only a couple of people, but really you want the response of the scientific community writ large. And by this, I don't mean like the entirety of the stuff, but like the people working in that subfield are going to respond,
Every scientist, everyone.
All of them are going to give their feedback. Yeah.
Yeah. Okay, so you've gone through peer review, and so what that's the benefit of this is kind of a quality check. There's all like a minimum threshold of quality that you're going to have from a reputable paper.
Yeah.
That doesn't mean if it's peer reviewed, it is therefore true.
Correct.
Right, but it does put it as more likely to be true or valuable than, say, a blog post like the Answers in Research journal, for example.
Yes. Yeah. It means that it is at least past the basic quality checks, and that there doesn't seem to be any obvious failings in logic. Now, and again, sometimes these things will still even get through peer review, right? Like sometimes a paper will have some sort of fundamental failing, and the reviewers don't recognize it, they don't see it. And when that happens, then you get responses from the scientific community because other people are going to read it, they're going to see it, and then they'll pin responses. When that happens, you can have it usually doesn't lead to full-on retractions unless there's like an actual like fundamental failure. Normally, it's just like a correction. Like the authors will be like, okay, you're right, we messed this part up, and then they will publish a correction. So you'll often see that on the paper as like an addendum or like or errata, whatever it's called, like the extra little thing that they add. And that's normal. That doesn't mean there was anything wrong. It just means like, oh, we missed, we didn't carry the one, right? Like those sorts of things happen. And just are, part of doing science.
Okay. You mentioned retraction. What does it mean if a paper's been retracted?
So for a paper to be retracted, it's actually kind of a big process. But typically it means that a certain number of scientists, a threshold has been reached that have written to the editors and said, we think that this paper is fundamentally flawed or fraudulent. And flawed is a little bit harder to get a retraction. Normally, if it's flawed, then the editor will be like, you write a response then, right? Write us a response, lay out your argument, and then we'll have them side by side. For fraudulent papers is often when you will actually get a retraction. And a retraction basically means that the editors publish a formal response and they say, we no longer support the conclusions of this paper as being reflective of the quality of research that we expect from this journal. And then they stamp retraction across the paper. And that's like the signal, the signature of don't read this paper. Don't expect anything from it. Gotcha.
So as Andrew says, peer review is not just scientists and their buddies just signing off on each other's stuff. Peer
review can be, there's a lot of jokes amongst like the scientific community about peer review. We have like jokes about reviewer 3. Reviewer 3 is always the meanest reviewer. Like, we have our own little thing about like reviewers can, they can be helpful, and they're almost always are helpful. Like I always feel like my paper is better after it's gone through review, but they're not always nice. They're not there to like make your life easy. They're not there to pat you on the back. They're there to challenge you, and they intend to be challenging and to like make you rise to their challenge.
Gotcha. Okay, so that seems like a good primer on the peer review process and what is a journal to start with. So if we're looking into like trying to figure out what's a good journal, what's a bad journal, one thing you mentioned just to underline is the subject matter that of journal you're applying to. Yeah. So can you expound on why that's important?
Yeah, so you want the journal itself to specialize in the topic that you're publishing in, right? So if I write a paper on population genetics of shore crabs, I would be foolish if I were to send that paper to like a physics journal, right? Like that journal, no editor can handle that paper. None of the reviewers that they have in contact could review that paper. And so that would be a fundamental mismatch of those two things. So what you want to be sure is that you are submitting your paper, or if you're, somebody wanting to read a paper, you want to be sure that the subject matter of the paper matches the subject matter that the journal itself specializes in. And that's normally pretty obvious. So to just like give a title of a journal, one that I publish in a lot is called Evolution. It's run by the Society for the Study of Evolution. So if you want to read papers on, you guessed it, evolution, this is a really good journal for that, right? Molecular biology and evolution is another one where if you're interested in the molecular biology of evolution, that's right. So like they're often very clear in like what the subject matter is. If the title is a little bit more opaque, like science or nature, then you would look into the subheadings. You would read like, okay, the journals always have like an about section where they say these are the things that we specialize in, right? And you can also get that a little bit from the other papers that they publish as well.
So I see this a lot when I'm researching pseudoscientific claims from creationists, or things like that. I often see a paper that's published in something that isn't the topic the journal specializes in. So like one thing that'll happen all the time is they'll publish to like a statistics journal, and they have statistics in their paper. Yeah. But their paper isn't about the statistics,
Right.
And so if you see something like that, that's a red flag, because it means, whether intentionally or not, they're avoiding the very people who would be likely to be able to spot problems with their research.
Yeah, they are. They're sort of they're subverting the peer review process, right? They're basically finding a way to sort of circumnavigate it. And it's also, I think, an important thing to sort of note is that a lot of like creationists in particular are publishing in, and maybe we can talk about this, like low impact journals. They're publishing in journals that very often have sort of a deficit of papers coming in, right? And so they tend to publish lower quality papers. They're publishing, and that's why they're publishing papers that are not necessarily in their field of study. They don't often have the same kind of quality of reviewers as like more reputable journals do, because like reviewers are volunteers. We don't get paid for it, right? So when the journal editor reaches out to us and says, "Hey, will you review this paper?" I'm like, I don't even know you. Like I don't know your journal. I don't know anything about. I'm not going to spend my time doing this. But if it's a respectable journal that I find is prestigious, then I'll take the time and I'll review that paper, right? So like you're only getting qualified reviewers from certain journals, anyways. So like in the case of statistics journals or mathematical journals, you can often slip things in there because the reviewers don't have any knowledge about like biology or they don't understand like the creationist dog whistling that often goes on in these sorts of papers. Like they don't catch that. That's not on their radar, you know?
So Andrew asks a good question here. Do scientists or can scientists, if they're perhaps less scrupulous, just kind of go from journal to journal, get rejected? Okay, that wasn't good. Go to another one, go to another one. Is that a thing that happens?
Oh, so yes, but not quite in the way it might seem. So one of the things that might happen. So let's say you write a paper and you think this is groundbreaking, amazing stuff. And maybe it is. It's a good paper and there's nothing wrong with it, right? But if I were to submit my paper on the population genetics of shore crabs, if I submitted that to the journal Science, they're not going to publish it. And it's not because there's anything wrong with that paper, but because it's not big enough. Right? Like science wants really big, flashy, groundbreaking, earth-shattering studies. You know what I'm saying? Mm-hmm. And so you have to kind of know where you're sending this to. So if I picked a journal like Molecular Ecology, which is a journal that will publish my population genetics of shore crabs, Molecular Ecology is a perfectly good journal. They publish high-quality stuff, but they are willing to publish more case studies and not so much of like these really big, earth-shattering papers like what you see in Science. So you could submit to Science, they reject it. You might say, okay, well, what's right below that? And eventually you will get to where it probably fits better anyways. So there's a kind of a fit that's not just subject matter, but that's also the level of advancement that paper is doing, right? So like how large is the advancement to the field that you're contributing? If you're making a gigantic advancement, publish it in Science or Nature. If you're just moving your little subfield a little bit, publish it in Molecular Ecology, right? Like that's sort of the way to think about it.
So from the outside looking in, it can sometimes be hard to tell what is or isn't a prestigious journal. Like I think most people who are interested in this kind of thing have probably heard of Nature. You know, so like, so what are some indicators that the journal you're looking at is legitimate? I think something you mentioned first is impact factor, which I think it's something that's often misunderstood.
It is.
So how would you go about using the impact factor? Well, what is it first of all? And then
so an impact factor is a kind of metric that was, I don't remember the year that it was started. It's a relatively recent thing, but the way to think about it is it's a ratio of the number of citations that all of the papers that you all of the papers that you have published have had over 2 years. So you basically just say number of citations, divide that by the total number of publications that you had. It's just this ratio. And so, for example, if you've published, or if you've got 1,000 citations and you've published 750 papers, then your impact factor is 1.3, right? So that would mean on average, each paper that you publish gets 1.3 citations. Now that's pretty slow. That would be a really, really low impact factor if you saw something like 1.3. For comparison, Science and Nature's impact factors are like 60. Okay, so that like it's really, really high for them relative to like 1.3. So impact factor is a powerful way to start. If you find, and maybe a helpful rule of thumb is if you see a journal that has an impact factor over about 6 or 7, then it's a pretty reputable journal. Once you've sort of crossed that threshold, this is a journal in which every paper is cited on average at least 6 times a year. That's a pretty good journal, right? So I think that's a sort of a good level to begin. Once you fall below that, then it gets a little bit trickier, and it's now you need to start thinking about other metrics to determine what is a good journal. For example, you need to think about things like who is publishing this journal. So if the journals are being run by a scientific society, so I mentioned earlier that the journal Evolution is published by the Society for the Study of Evolution. This is the original scientific society for studying evolution in the United States. So it's a very prestigious society, but its journal only has an impact factor of like 4.6, right? So it would fall below the threshold that I just said, but it's published by a prestigious society. And so it publishes good, respectable work, right? So I'm looking at the sorts of societies, and then you can kind of Google the society. So when you go to like the journal's website, they will have published by this society on it. Google that society. You can Wikipedia it. You can learn a little bit about that society. When was it established? How many members does it have? Does it hold annual meetings, right? Like those sorts of things will give you a lot of insight into whether this is like a legitimate journal if it happens to fall below that impact factor.
Andrew asks, in reference to the impact factor, so would the impact factor, like what is good, be field dependent?
Oh, good point. Good point. Yes, I suspect that's probably true. So I'm speaking more from my field. Yeah, that's a really good point. I would say that probably if you're in the 7 or 8 impact factor, I would suspect you're good in just about any field. I wish John were here to correct me on this. But at least my field and it's pretty broad. Evolutionary biology is a pretty broad field. If I see a journal for 7 or 8, I would think that's pretty good. But the society is a safe way to think about it, just about, in any field. Gotcha. For sure.
So high impact factor, definitely good. Low impact factor doesn't necessarily mean it's bad. It might just be a very niche topic, or a smaller field. But if you see that high impact factor, then you're probably good to go.
Yeah. If you see a high impact factor, you're always good. And then if you do start seeing a low one, think about what it's publishing in. So the example I like to give is like taxonomic journals. So like journals that are doing like species descriptions, right? No one is going to cite that paper. They're just not. And it doesn't mean it's not good work. Like it's a ton of work to describe a species. I've done it. It's really, really challenging. But I'm the only person that's ever cited that paper, and I probably will remain the only person because it's just like it takes someone working on that specific undescribed species to cite it. You know what I'm saying? It just doesn't garner the same level of citation. So those journals tend to have very low impact factors. But you know that because it's a taxonomic journal. So also think a little bit about what are the sorts of things they're publishing.
Okay, cool. So now that I think we've talked about the journal, and so you've gone through and you've found a journal and you feel like it's pretty good. Are there any ways to find journals that are bad? So we've talked about how to find a journal that's good. Are there ways to do a quality check to cut out bad predatory journals?
Yeah, definitely. So there's a couple of easy ways. So if you're just thinking about the journal itself, maybe you haven't seen a paper yet. You're just looking at the journal. You go to their website. Predatory journals often have telltale signs of their websites. Very often look like, I don't know, MySpace pages from like the early 2000s. Like look at sort of like, does it look good, right? Does it look like it's well made and has high quality? Because I've seen so many predatory journals that look really bad and that are like the websites look really bad and really poor. And you can also take this to the copy editing of the papers themselves. If the papers themselves look like they were typed up in Microsoft Word, it's a bogus journal. Like legit journals have a very specific sort of copy editing style that they do that gives them an air of legitimacy. So like even the very basic sort of copy editing visual stuff. Then when you're reading the paper, look for things like basic grammatical errors, sloppy language usage. Like those sorts of things are telltale signs that this did not go through a legitimate review process. That there was no legitimate editor that really looked over this, and they were just going to publish whatever they got, right? So those are like the very basic, I think the most simple ways of kind of ruling things out. But you can also just Google the journal very often. And you can find a lot of these journals have like Wikipedia articles and stuff warning about them. There's even a list. Is it Beall's list? Beall's list. So if you go to Beall's list, it will actually give you, it's a couple of hundred journals in there that are known predatory journals and known predatory publishers of journals. So if you see a journal, look at its publisher, and then see if that publisher is listed on Beall's list, and that will tell you it's probably a predatory journal. And so to be clear for everyone what a predatory journal is. So predatory journals are journals that will publish literally anything. They look like real journals. They have sort of a faux journal aesthetic, but they're not really peer reviewed, and they're sort of pay to play. So the authors have to pay a fee, and then the journal will just publish it, and then they just sort of pretend like it was peer reviewed.
Now, would those journals tend to be open access?
They do tend to be open access, yes. And the reason for this is because the authors themselves are paying a lot of money up front, and that allows it to be open access. Almost always predatory journals are going to be open access. There are like legit journals that are also all open access. There's several journals that have tried to sort of move to that direction as a way of like just making science more accessible. But yeah, there's this kind of tug of war there, and that the authors are now we're all upset that we have to pay for it.
So yeah, when I'm looking at a good journals, if I see that a journal's open access, it doesn't mean it's bad, because there are completely legitimate good journals that are open access for good reasons. However, it does mean like not all open access journals are bad, but a large portion of bad journals are open access.
Yeah. If you already had like a couple of red flags, if like a couple of things already seemed a little weird, and you could just freely download it, maybe this isn't what you want to be relying on.
Okay, so we've done our job. We found what we think is a good journal. So now we're going to focus down on the paper itself. So for starters, Andrew had a question. He said, what's the difference between an opinion piece, a perspective, et cetera, in the literature? So I've seen sometimes like you got a paper, but I've also seen like letters to the editor or things like that. How do those differ?
Okay, that's a good question. So the typical way of publishing is and they're called various different things in every investigation, main article, whatever. There's the typical research article, right? That sort of follows the introduction, methods, results, discussion form that you expect, goes through rigorous peer review. That's your basic, typical scientific paper. But then a lot of journals will publish other things, as Andrew pointed out. And one of them are things like perspectives. So what perspective pieces typically do is they're either invited, an editor will look for someone in a field and be like, we want your thoughts on this arising controversy, things like that. And so they are often more think pieces. They still undergo peer review, believe it or not. Like they're not peer reviewing for stats and stuff, but they do peer review for logic and like, are you representing the field fairly? So perspective pieces are very often think pieces. Sometimes they can be critiques of recently published things, or they can be attempts to synthesize ideas. The way to sort of think about them is as a think piece. Like, don't go into them thinking they're fixing to give you a bunch of hard data. That's not their point. Their point is to just put forward a sort of conceptual idea. There's also things like book reviews. There are letters to the editor was one that you mentioned. Letters to the editor are very often if there's a paper that was recently published and people think that there's some issues with it, but it's not going to be like a full retraction, or like they don't want to write a full paper, then they'll just write a little letter to the editor and they'll be like, these are some things that we disagree with Dr. So-and-so on. And it's normally just like a few paragraphs, right? And those are often not peer reviewed. Those are, again, they're just letters to the editor, and then it's up to the editor to decide if they're going to publish them. And they don't always, but if they think that the people are making a good point, then it's to the discretion of the editor to publish it.
So letter to the editor or something like that shouldn't carry the same weight with us as a full paper.
Absolutely not. Yeah.
Got it. Okay. So digging into the papers themselves, we've got a paper in front of us. We're trying to read it. I think obviously the first thing you do is read the abstract, then stop, or actually read the part of the abstract until you get to something you like, and then immediately stop reading.
That's it. That's the way to do
it. I say this facetiously because this happens all the time when someone will like cite a paper, like, oh, this proves my point, and it's like, the first part of the abstract is asking the question that they're trying to
Yeah.
address, and that's the thing that they agree with. And then if you read the next sentence, they're like, and then we looked into it, and that's all bullshit.
Yeah.
Like, you know.
Yeah.
So,
Um,
can you talk about like what is an abstract? Like, what's the
yeah.
point of it?
Yeah. So I think when you find your paper, maybe just before we get to the abstract, is the authors list, right? So you've got a good journal, you've got a paper that you want to read, and then the next thing I would check is who's the authors of this paper. And this is a sort of a really important thing because you want to be sure that these people actually study the topic that they're writing on. Oftentimes, the first couple of authors are grad students and postdocs. So it's actually usually not super useful to look up the first few authors. It's normally the last author that you want to look up, either the last one or the one just before or the last two. Those are the people whose lab that the work was conducted in. So they oversaw the project. And this is maybe a little bit of insider knowledge. Like people often don't think about this, but the ordering of the authors, first author did all the work. They're normally grad students and postdocs because believe it or not, those are the people that actually do science. And then the very end is what we call the principal investigator, the PI. And that's whose lab it was in. So you look up that person. What university are they at? What lab do they run? What are the recent papers they published? Like really do research into who that person is will give you a ton of insight about the quality of the paper that you're fixing to read. Just as you're going forward, think about that. And you can also think about it in terms of like the connections between labs. I think it helps people like think about the scientific community of understanding, okay, this person works on this and this person works on this, right? There's very often these connections that you start to see as you read through literature. You see how these labs are connected. So I would start, do a little research on the authors, and then abstracts are useful to know if really the way I think about an abstract is this paper going to address the kinds of things that I'm interested in knowing about, right? Like it's just supposed to give you a little paragraph of like, here is the problem, here's how we think we can solve it, here's how we speculated we might have solved it. That's an abstract, right? Now, you're never convinced by an abstract. An abstract is just to convince you to read the paper, not to tell you what the paper is or whether the paper is legit. It's just trying to get you to read it. And then from there, you start. And I always start with the introduction. People, I think, sometimes like to go straight to methods. Start with the introduction because the introduction lays the foundational groundwork of the idea that they're looking to answer. And I think it's really important to know that to understand a legit paper will have detailed background on this idea and who is doing work in this idea and what are the things that have been found previously, right? And so like every paper in science is building on work that came before it. So if you read an introduction and there's very little citations, there's very little exposition about like what has come before, that's a red flag to me. I want to see you build up the argument based on pre-existing work. And the introduction can also, if you don't really know a lot about the topic, it can give you places to look further. You're like, oh, this is interesting. There's a citation. There's another paper I can go and check out more from, right? And it also tells you, are they representing this person correctly? I'm going to go look at that paper and make sure. So that's what the introduction can help you do.
That question, are they representing this person correctly? Would it be accurate to think that the introduction isn't subjected to as harsh of a peer review as the rest of the paper? So like when they're like, would a peer reviewer necessarily chase down all of the different citations and make sure that they're being accurate?
My hope is that they do. My suspicion is that they don't always, right? It's like one of those things where there's a lot of peer reviewers, and generally when I've been one of the reviewers, if I read a sentence and I recognize the citation and I'm like, that's not what that paper's about, right? Or if I read a sentence and I think you should have cited this paper, then I will make those statements. But if I don't necessarily know exactly what the paper is, I will at least go to the citation, look at the abstract of that paper and make sure it is what it looks like it is. I'm not going to read the entire paper. But you really only have to do that if they're saying something that feels a little off, right? Like if they're saying things that, oh, everybody knows this is part of consensus, like we all already agree, then it's really not worth your time to track down every single thing. But if I notice something that's obviously wrong, I'll point it out. And I've had other reviewers I've been on panels with that have picked up on things that I missed and said, oh no, that was used incorrectly. And that's why we have several of us, that do this so that we can each sort of catch mistakes that the other of us don't see, right?
I was just laughing there because a Prender said it would be awesome for Zach to react to today's debate. And it's only funny because Zach and I were talking about this exact debate before things started. I won't go into what we were saying. I'll leave that for a reader to guess. It's funny that came up. So that you can look for that like next week, right?
Yeah, for sure.
Okay, so that's completely derailed my train of thought. We talked about the introduction. Okay, so the introduction is supposed to give you like background on the problem, summarizing kind of research that came before, so you get like, which I found very helpful when I'm looking into a topic. Because I don't know this background necessarily, and so that's been super helpful for me. I don't necessarily take everything as gospel truth because, like you said, they're not necessarily going to track down everything. But like, if I read a bunch of papers on the topic, they're all kind of saying the same stuff and they're all peer reviewed, and it's probably good, you know.
Yeah. I think that's fair. Yeah, and like you said, I think it's a good way to sort of establish that background, and not only for the reader, but also to establish that the authors know what they're talking about and they know how their work fits into the broader ideas of the field.
Okay, so we've read the introduction. Now, where should we go next? I think a hurdle that some people run into is if you just read the paper, it's very quickly going to become technical because, I mean, it's a paper on a technical topic, right? It needs to. And I know, like, I have some expertise in math, so I can often at least look at the math and make sure, like, the thing they say the math should be doing kind of makes sense with what there's like the math, right? But I don't know population genetics, you know? So like, how would a layman go through and like kind of parse that, and where should we go next?
Yeah, so this kind of gets pretty complicated. Depending on the topic, some things are easier to do than others. Often, if you are like a layman and you, let's say, have no training in statistics or in experimental design or anything like that, reading the methods themselves are probably not going to get you anywhere, just because they're not written for you, right? Like they're written for other people in the field to know what they're doing, and so like they're not going to be written in a way that's very digestible or understandable. However, a good result section should be digestible, in my opinion. They're not always, and that to me is a fault of the authors and the editors not cracking down on them a little bit harder. But results should generally be interpretable. Even if you don't always follow all the little jargon and stuff, if you see a p-value and it's really small, right, that signifies statistical significance. You know, like those sorts of basic things you should be able, I think, to get out of the results. Also, like, you know, the figures can be really helpful. I think we're visual species. I think we do better when we look at graphs than when we read the words. And sometimes if you don't see a graph of a thing you want to see, very often you can go to their supplemental material and they have a ton of extra graphs there that can really help you walk through things. So in lieu of reading the methods and like getting too deep into the weeds of some of the results, I really recommend spending some time seeing if you can understand the charts, the graphs, the tables, those sorts of things. They always have little captions that are supposed to guide you through what's happening in the figures. I think that's sort of maybe the best way to try to digest the actual physical results is by figures and then reading the results as best as you can. Again, there will be some technical things depending on the kind of field you're reading through. But you should at least be able to get the gist of what they did, I think from the results and the figures.
Yeah, so the way I usually do it is, hold on. John was asking for a link. So I start in the introduction. I start in the abstract introduction, skip everything else to the results, see what they said, and then I kind of go back and look over the rest of the paper with that context now.
Yeah. I think that can be really helpful. It's like sort of see the outcome and then maybe go back and make sense of the methods. And in fact, some papers are even published that way. They'll have intro, result, discussion, and then the methods are like at the very, very end. Just because I think there's some research that shows that makes the whole thing a little bit more digestible that way. But yeah, I think the things that most people will find the most beneficial are probably the introduction and then the discussion. The discussion is where you then try to tie the things that you found back into the introduction. And so you're drawing that through line between this is the topic, this is what we're interested in, these are the problems that we're trying to address. The discussion brings in some of the results and stuff that you found, and then you interpret those results in the broader context of the field. Discussions can have, beware of discussions in that they are permitted to have a little bit of speculation. That's what they're there for. They're supposed to allow you to speculate on results and speculate. And by speculate, I mean, how do my very specific results, sort of reflect on the general patterns of nature, right? Like, so that's what I mean, is that you're trying to draw a broader inference of how nature works in the discussion. So if that worries you, or if you think they're drawing too broad of conclusions, go back to the results. Be sure that you understand if you think that's too far. But like, as reviewers, one of the things that we're the most we scrutinize the most is the discussion. We really, really try to hammer on if we think that this is too speculative, we say this is too speculative, you need to take it out. I've had that told to me many, many times, that I'm being too speculative and I need to take it out. So we do allow some speculation because I think it's important. It's what drives the next hypothesis, right? So you're like, okay, I saw this. This is how I interpreted it. If my interpretation is true, then I should see this next. And very often that is setting up the next paper in that lab. Like that thing that they said, if you look at the very next paper they published, it's probably testing that idea. That's the way they kind of string these experiments together and sort of build research programs, is in this way.
Gotcha. So look at the paper, abstract, introduction, results are the most important pieces to hit. Mm-hmm. Look for the graphs if you're trying to understand something. So once you've gone through all of that, the next piece, so you've read the journal, you read the paper, you feel like you understand it. The next thing that I usually do, or actually I've usually done this stuff by the time we get to this point, but I usually look at who's cited this paper and why, right? Yeah. So this gets to a question that Scott Duke had. You mentioned like dissenting letters and prospective statements and stuff. How, like, if they're published, how would we know? Those letters would be citing the original paper, would they not?
They do, yeah. So Google Scholar is your best friend. Google Scholar, to me, is the best way to find some of these things because it's arranged in such a way that makes it easy to see who has cited things. So if you just put the title of the paper in Google Scholar, on the bottom, it'll just have like a link that says cited by X number of individuals. You click on that and you can see everyone that has ever cited it. And that includes all the dissenting voices will be in that citation list. And in some instances, if the dissenting voices wrote a direct response to that journal, this is not always the case. They do this if they really think that they need to make a strong point. They'll write it straight to that journal. Then the journal will often publish it as a companion piece. So when you go to that original paper, it'll be like, see response by blah, 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 like in the top right, and then you can click on it and see it. If folks remember the big paper from Monroe a few years ago on mutation bias in Arabidopsis, that was like a huge paper that caused a big controversy that because mutations aren't random, it caused this whole thing. There is now a response in the corner of that paper because people wrote responses to it.
So you mentioned Google Scholar. Andrew asks, how do you tell a phony citation from a good one? So like when I'm looking at citations, the things I'm looking for is, so it's got like more citations is great. Like that means more people are using it. When I'm looking at it, you can tell me if I'm thinking about it wrong or not. I look for, first of all, are the citations all the same person citing his own paper? Now, if there's anything wrong with that, like if you're doing continuing research, you're going to cite your old research. But if like they're the only one citing it, that might tell you it's not getting broader appeal. Also, that's where you're going to find like, and it's usually pretty obvious in Google Scholar. If I look through the citations, the title of the responses seem to be pretty clear that they are responding to and disagree with the original paper.
They will be. Yeah.
So if you just kind of scroll down through Google Scholar, though, be aware that Google Scholar also will give citations that aren't themselves like peer reviewed. Sometimes like books will show up there and stuff, so you have to be a little bit cautious. But
yeah. I have a citation on one of my papers from Gunter Beckley from like Evolution News, and Google Scholar picked it up and put it on there. So I always thought that was the funniest citation that I've ever had. But no, that's a good point. If they cite themselves, and this is also, so there are some checks in the journal system, and that if a journal consistently publishes papers and those papers are cited by the authors themselves more often than not, then that journal gets flagged. and basically they can lose. It's not accreditation. I forget what it's called. There's a certain it's kind of like an accreditation where there's a website that sort of keeps up with these are legit journals kind of thing, and they reevaluate journals every few years, and journals that violate certain things, like if they suspect them to be predatory, etc., then they get flagged. And one of the things that can get you flagged is if you're publishing papers and only the authors are citing those papers. So there is a little bit of a check on that problem as well. But yeah, watch out for, if you're reading something and it's a bunch of bogus citations, they're usually pretty obvious that they're bunk.
That list of good journals, is that the Master's Journal list, or is that something completely different?
I think it's published under I never can say this word correctly, and I've never said it out loud. Clairvoyant. I'll write it out. But it's the one that how can I put? Yeah, I can put it in the private chat. Oh, maybe I'm spelling that wrong.
Clairvoyant. I'll just put it in the comments and the.
All right.
There we go. CL, and this is it. CLAIRVANT.
Yeah.
Clairvoyant.
Yeah.
There you go.
They basically like review journals, and they like look for certain red flags. And they're also the ones that keep up with impact factors and stuff like that.
Gotcha. Okay. So another thing I look at when I'm looking at cited research is like, what are they citing the paper for? I find this a lot when I'm doing Shredder stuff. Is they'll cite a paper not necessarily for its main conclusion, but for one little piece. So like a good example of one that came up somewhat recently was the Waxes study. For those who've been up to date on Shredder, if that's the case, why are you doing that to yourself? But if that's your thing, it's wide angle X-ray study, and a lot of people have cited that, but almost all of them are citing it as hey, they did this cool thing with X-rays, nothing to do with like it working on linen,
right?
And so that's another thing to be aware of. The person who like in Google Scholar, you'll be able to see kind of like read the context of their citation. Are they citing it because they're using the result and think it's good and it's important?
Yeah,
that's one thing. Are they citing it because they think it's terrible? Are they citing because they don't care about the results at all, but it's just like they did some other thing they think is cool,
Yeah, especially if you're using Google Scholar as a way to sort of check the legitimacy. Yeah, you can definitely click on those papers at the site, and seeing how they're using that citation is definitely a way to like be sure that they're legit journals that are citing them, and that they're actually being cited for what you think they're being cited for.
Prixie of the Shroud of Turin asks, why are you doing it to yourself? Look, I don't have a problem. I can stop anytime I want. Okay. I don't know. It's just kind of like one of those things that's like one day I woke up and I was the Shroud of Turin guy. I don't know how this happened.
I'm here. I can't walk back out of this now.
So it's almost a self-fulfilling prophecy, right? So like I did the initial, this is just complete aside, so feel free to skip if you're watching this in the future. But like, so I did the initial response, and like it got a lot of views, and people were like, we want to see more of this. Like, we think this is legitimate. So I was like, okay, so I'll actually do this seriously now. So I went and I did like a whole deep dive, right? And now I've done a second deep dive. And the problem is when I'm looking to make a new video, I have all of this Shroud of Turin stuff in my head. Yeah. I don't want it there, but it is there. And so if I'm going to do a new video, a new Shroud of Turin video is actually very low effort for me because it's already all in here. I don't need to do a ton more research. I already know it, right?
Yeah.
So like the barrier to entry, and every time I do another one, it becomes like I'm just digging myself deeper in this hole.
Yeah.
Anyways, okay. All right, we're talking about citations, and basically more is better, provided they're good quality citations. So a bunch of citations would tell us if they're like from other people using the research that it's well received in the scientific community, right?
Yeah, that it's well received, that's generated lots of discussion. The kinds of papers that you see have a lot of citations very often are synthesis papers. Believe it or not, they're often not like individual articles. Individual articles make the biggest splash in terms of like contributing the individual, sort of data points, but the papers that very often get cited the most are the big synthesis ones that bring everything together and show how everything is connected.
That'd be like a meta-analysis.
Yeah, like meta-analysis. Sometimes they're literally, I think the American Naturalist publishes what they call synthesis papers. And these are generally just like people coming together, bringing all their individually published articles and being like, we think all of this collection of data suggests this new big thing, you know?
Mm-hmm.
And those are the ones that get cited a bunch because they generate the most discussion, right? And so people are like really thinking about it and talking about it.
They also, just by their nature, have a massive sample size because they're
they
taking the
do
sample size from a bunch of other things.
Yeah, it's a lot of studies, and they're usually looking at like trends across studies. So you know they've got thousands and thousands of data points that they're looking at, and they're like looking for really big trends and things like that. Yeah.
Okay, so I think it's safe to say that if you see a conclusion in one paper, and only one paper, that you shouldn't immediately be convinced.
Yeah.
You should. So this is another example, going back to the waxes thing. Like basically nobody but the people who published it have done anything with it. And so if on the one hand it's kind of new, so like that's understandable, but that also means that we as lay people are kind of relying on the experts to tell us if this is good, and if it's new and hasn't been cited, well, we don't know whether it's good, right?
Yeah. I think if you take nothing else away from this, maybe the most important thing is never make a conclusion based on one paper. Even if that paper seems super convincing to you, be sure that you've read more than that one paper. So not just one paper, but like a series of paper if they're all written by the same person. You know, like don't fall into like cult of personalities and follow like one scientist, and this one scientist has a crusade and writes just these one papers. Like be sure that you're reading from multiple authors, multiple labs are working on this idea, and there's been a consensus drawn. And this can be, I think, maybe the hardest when there's sort of like controversy, or it's like a new idea and people are debating over it. This is when it can be the most difficult to know what side to take or who's right or who's wrong. And to me, the best sort of safe thing is don't take a side. Just say, we don't know yet. If you see two sort of labs going head to head and they're doing their back and forths, this is how science works. It can take many years to resolve these sort of big issues on as Andrew says, on the cutting edge of research, right? When that happens, if you're looking in, you just have to wait, and it will get resolved, but it's going to take some time. And yeah, you have to wait until the consensus is finally drawn and the studies and the data are all in.
Yes, I don't know is always a valid answer. And as skeptics, part of doing good skepticism is recognizing when we have insufficient data to make a good conclusion, in which case we should just refrain from drawing a conclusion, right?
Yeah. And I think it's like scientists like to argue, we like to debate, and very often debate is the most polemic when there's little data. Right, like when it's hard to resolve an issue is when people like really want to get entrenched in their ideas and stuff. And we often think of that as maybe a bad thing or like a failure of like human nature. But in the history of science, it's those sorts of things that have really driven innovation. It's when you've got these big sort of explosive arguments between big personalities, all the other labs want to contribute and they want to see if they can be the ones to solve this problem, right? And so it generates a lot of research. And so I think that scientific controversies are important, and like scientific debates are important. It's very important to like have these sort of, even if they seem maybe petty or vicious to people on the outside, I think they drive innovation and they drive people to want to, you know, get dirty and find the answer. But it's, you know, it's not something that's just going to be resolved overnight. You have to wait.
Fair enough. I wish you scientists would hurry up and, you know, just solve all these problems. I hear that we're actually going to be working hard in the U.S. to make sure that happens by cutting all funding. That's how you do it, right? You stop all money, you know.
Yeah, that'll definitely resolve all of the scientific problems for sure.
Okay, so Andrew has a question. Related to this, how often do new interesting results turn out to be wrong or not as significant as people thought?
I haven't, my intuition for this is that there is probably a scaling relationship between how significant and revolutionary the new idea is and how often it fails. That I suspect that the more revolutionary an idea is, the more likely it is to be wrong. And that it's the little progress, little by little, gradual improvements that tend to make the biggest contributions to moving the field forward. Every really, I'm thinking back on like some of the biggest, most recent controversies. All of the ones that I can think of off the top of my head have turned out to be problems, have turned out to be something wrong. There was not that long ago, there was this really big paper about human migration, and this was about human evolution, and that there was supposedly a bottleneck that had occurred in humans 900,000 years ago, and yet the signature was not seen in any African individuals. The signature was only seen in Europeans. Well, that doesn't make any sense because all humans were in Africa 900,000 years ago, right? And so like everybody was like, well, that can't possibly be true. But all the news headlines picked it up. It was everywhere. And this was maybe 6 months ago. It was all over the place. And it took one paper to redo their stats and say, no, you did your stats wrong. Here's why your model is incorrect. There is no bottleneck 900,000 years ago, right? Now, the problem, of course, is that the news has already run with this story.
Right.
They've already published it everywhere and people are already convinced. And I've had to debunk it on in YouTube comments and stuff, but because people just jump to the first flashy conclusion that they see. But when you see something like that make this like really big radical claim that would really kind of fundamentally challenge our current understanding of things, take that with a really big grain of salt.
Yeah, I see this every few years. There's always a thing where so and so lab has, have they shown a particle that moved faster than light? No, they did not.
Yeah.
No, they didn't. It's just every time they just messed up their math. There was something wrong with their experimental setup. Yeah. If someone is saying a thing moved faster than light, they're wrong. You could just, if you want a heuristic, go with that. Basically, if you see a paper, you see a headline, right? And it's this paper overturns our understanding of science. No, it didn't. Just calm down. No, it didn't. But on that brings up a follow-on point. Sometimes it can be hard, even if you do all these things that we've been talking about, and you try your best to understand what a paper is telling you. Or you'll often hear about it, not from the paper itself, but from, some source, right? Mm-hmm. So if you're trying to get assistance in understanding what a paper is telling you, where should you go and where should you not go? I mean, to start with, don't go to the science headline of the Daily Mail or something like that.
I wouldn't recommend that. For me, if I were like a layperson and I was trying to understand a paper that I just couldn't seem to like wrap my brain around, my instinct, and I say this as a scientist, my instinct would be to actually email the authors. And in this case, email the first authors, because the first authors are the grad students and the postdocs that carried out the research. And they will probably be happy to explain it to you. I say this because like we do this because we love it. Like, you know what I'm saying? Like we really like doing this. And if a person from the general public is like, I tried to read your paper. I don't understand it, but I think it's cool. Could you maybe tell me in like a really simple way what it means? They would probably be ecstatic by that. That would probably make their day. I know as a grad student, it would have made my day if somebody like reached out and was like, I read your paper on amphipod population genetics and I want to understand it. Like that would have just been amazing. So my first instinct is to tell people, email the authors, genuinely, like they will probably respond to you. If they don't, then there are other people that you can often find that will understand this stuff. Sometimes even sources like Reddit can sometimes be helpful, like the evolution Reddit. There is like actual genuine experts that hang out there and that can often sort of give you feedback on papers if you don't understand them. There's plenty of YouTube channels as well that you can like find evolutionary biologists. And we can often help you as well. So yeah, like use the resources that you see around you, and people, and somebody will eventually end up helping you out.
Just be careful. The further you stray from the peer-reviewed paper itself, you're moving out into the wild. So you have to know, and I'm trying to give you advice on how to do research and telling you just know how to do it, and that's not very helpful. I understand that. You're gonna have to build this skill up over time.
Mhm.
You know,
Yeah.
start with the papers themselves, and then move to newspapers that are like specialized in reporting on science, or sometimes the lab or the organization that published it will put out a press release
Yeah,
themselves,
that's a good point.
and
Yeah.
here's two lay people, this is what our research means,
Yeah.
right? And that can be a good reliable place to look. On though the emailing of the people who wrote it, I've had nothing but excellent results doing this. They don't always respond, but every
Nice.
time I've gotten a response, they've always been, I get the impression they're ecstatic that someone read their paper.
Yeah.
And
Yeah.
and so like, you're dealing with a human being who's going to be answering your question out of the goodness of their heart, and you're not paying them. So don't be a
Mhm.
jerk, be polite, do that legwork first. Don't like go with your half-baked question you could have answered in 2 seconds
Yeah.
on Google. But if like you put in the good legwork and you have a good insightful question, or a question you can't answer and you've tried, then pose it politely and you'll probably get a good response.
Yeah, yeah, especially if you like can demonstrate in the email that you really read it and tried to understand it. I think that would like immediately sway it would immediately sway me to respond for sure. And I can't imagine any of my colleagues saying otherwise.
Yeah.
Yeah.
Let's see. I'm just looking at our notes to see if there's anything else that I wanted to mention. One thing that just kind of from a philosophical standpoint, if I'm doing research for a video or looking into a claim, the kind of the way I start by approaching it is I ask myself, what are my biases? What would I like to be true? Or what
Mhm.
do I currently think is true? And then I do my best to prove that wrong if I can.
Mhm.
So I start by looking at sources that disagree with me,
Yeah.
sources that would tend to be hostile to me. I look at the other side and see what
Yeah.
they're saying, because there's the confirmation bias. That's the bias where we tend as humans to we put more weight on things that agree with the thing we already thought,
Yeah.
right? But there's another bias, the anchoring bias. And so the first thing you see, your brain anchors to as that's right. And then like
Mhm.
judges everything else off that. So I try to use my two biases to fight each other and make the first thing I look at something I would usually disagree with.
Yeah.
Um, do you have any other kind of heuristics or tricks like that you've picked up?
Oh, that's interesting. So very often I find that when I'm reading papers, I'm reading them to learn either techniques or learn something about a field I don't know a lot about. It's not terribly often that I'm reading like fighting ideas or two competing viewpoints per se. But when I do always try to say, okay, I know that there's two sides to this. And generally, if you're reading a sort of a controversial thing, you know there's two sides to it. And if you don't, then you can look at like the citation, like who is citing this paper, who are they citing, and very often the paper will be like, we are responding to so and so. It's pretty obvious that there's a back and forth going on. And try to read them with as open as of a mind as you can. I struggle with this a lot because I also have like my pet theories and my pet ideas about the way I think the universe works. But it's very important that especially if I see a paper that comes out and like the headline is against my pet theory, I always make a point to read it, because even if I disagree with everything that I read, I want to be sure that there's not some argument there that I've just like missed and I've never seen or never heard, and because I don't want to believe things that aren't true, basically, right?
Mhm.
Like I have my pet theories and I have things that I gravitate to that I just personally like, but if it's wrong, I want to know it. I want to know that it's wrong. And so I think it's important for us to always challenge the ideas that we hold in our head, or we're just going through life believing false things. And I don't want to live. I don't want to live like that. So
Yeah, Pibble Punk brings up a good point that it's important not to get overly comfortable with what you think you know. Sometimes if you're bringing up a fact out of your head, and it's particularly if it's not in like a field you deal with all the time,
mhm.
then question: How did I know this? It's actually, brains are really really bad at storing how they know things, because if you think from like an evolutionary perspective, like that, who cares how you know it? The point
Yeah,
is that it worked and you're not dead.
yeah,
So.
yeah,
So
yeah,
that's something we have to be deliberate about. But at the same time, Pipplepunk again brings up a good point about kind of the nature of science. We were talking about how like new papers don't usually like overturn the
Mhm.
whole thing. And I think
Yeah.
this is often a misconception about how science works. So they point out um, a lot of fields are well studied and we're figuring out the details are nuanced, not making huge sweeping discoveries. And that can be true. It depends on the field.
Yeah.
But regardless, science is, I like to describe it as the process of becoming less wrong over time.
Yeah.
And so like you're narrowing down on the truth, and the past observations, whatever theory we had. So like Newtonian physics is the one I always use when I like
Mhm.
we went from Newtonian physics to relativistic physics to quantum mechanics, though those kind of overlap, but whatever.
Yeah.
Newton had ideas, and all of the observations where Newton was right and predicted things, any new theory has to agree with Newton. They have to,
Mhm.
because that's what the data said,
Yeah.
right?
Yeah.
And so if you're coming on a claim that says Newton was wrong and everything he said was false, well, clearly not, because we
Yeah.
still use Newton to go to the moon, right?
Yeah.
So, you know.
Yeah, and I think it's also that's also true in like evolutionary biology as well, right? Like universal common descent is something that we've well established at this point. So any sort of theory in biology that's like universal common descent is wrong has got a lot of data to have to deal with. And so what we end up fighting with are like increasingly narrow things, right? So we're going from universal common descent as like the sort of the starting fighting point to now narrowing all the way down to like, well, is evolution mostly natural selection? How much is genetic drift play? It's like working out the nuances of the details that are what we're really fighting over. And to us, like, to be clear, that might not sound like a sweeping discovery to some people, but to us, like, this is a heated debate. Like we're in the thick of it, and we feel like we're still standing on the last frontier, sort of thing. Like even if it doesn't feel like a big sweeping discovery to everyone else.
So I just got a couple questions that I started that I didn't fit in right, but I thought are worth asking. So
Yeah.
both from Scott, actually. So Scott asked, how much encouragement do academic institutions, like how much pressure incentive do they put for people to do peer review? Like you mentioned, it's like kind of volunteer. They're not paying you. So like,
Yeah.
why do it?
There is, in my experience, effectively none, which is a big problem, and it's one of the big problems in just like the sort of equity of the peer review process, and that we are sort of expected to just be, I don't know, saints. Like we're just supposed to volunteer our time because it's part of like doing the morally good thing. I don't know. It's what keeps the process going. There's a lot of discussion, like when you hear about the crisis in peer review and those sorts of things, like often what they're talking about is like trying to make the peer review process more equitable, because often what ends up happening when you have this sort of, I don't know, it's not really a tragedy of the commons, but it sort of feels like this thing where a few people are doing the bulk of the peer review, or they're putting in a lot more effort in peer reviewing and spending time peer reviewing than other people do, And so like people are like, well, I don't get anything from this. Why should I peer review 20 papers a year? Whereas other people are like, well, the journal sent me this. I feel morally obligated to do it. And that's how I often feel. I've reviewed almost every single paper that has been sent to me. I've reviewed 3 papers in this past month, which is a lot of work in a month to review a paper. Like it takes a lot of time and effort, because I just believe in the process, and I believe it's worth my time to contribute to the process. But there's nothing other than this sort of moral imperative to make people do it. There's an argument that a lot of these journals, especially like if you're a big journal like Science or Nature, you should pay reviewers to do it. That's an argument out there because that is labor, right? They're putting in a lot of work. There are some other newer ways that people have done this. So like, for example, a lot of people nowadays will put the journals that they review for on their CVs. So like my CV has like a list of journals that I have reviewed for. That's something that we really only just now, just like in the past couple of years, started being an acceptable thing to do, as like part of your service, And I think that's, those sorts of things can be seen as incentive building your CV. But yeah, it's one of the things where we definitely need to think about new ways to like get people involved in the peer review process and make it more equitable for sure.
Talking about enhancing peer review, I hear the problem of replication being brought up a lot and how
Mm-hmm.
there's not enough of it. So Scott was asking, like, how many papers are the result of previous experiments or like reproducibility? How this is a little bit off topic, but like, is this really a problem in peer review as it exists?
So I can't speak for all fields of science, in that there are some fields where I've seen like some big meta analysis that seem to show like issues with replicability, but I'm thinking of fields like mostly in psychology, and then some fields in medicine. You're seeing these sorts of difficulties with like just like replicating studies and like find like when you do a follow up, you just don't get the same result as the original study, sort of thing. To some extent, I think that's fine. Like that's like okay, here's the next result. We found the first one was wrong. We updated. We now know more, right? Like I think that there's nothing necessarily wrong with that. There's maybe sort of a bigger question about like how often do we do these sort of replicate studies? And the answer, at least in my field, is we don't. You rarely ever will try to recreate the exact same experiment, right? So like if I do a certain experiment that's in like a natural system, it's virtually impossible to recreate that exact same environment in that exact same system again. But we do these sorts of replicates, and that often when we publish, we have not just one thing, but we have many sort of site replicates. So if you think about like a common garden experiment, you don't just have like one plot, you might have 50 plots. And so you have some sort of statistical, not certainty, but some sort of confidence in the results that you're getting from the replicates within the study. Yeah, I feel like I'm being a weasel about this, but is there a reproducibility crisis? I find it's a really complicated question to answer, at least from evolutionary biology, because we often don't do the kinds of experiments that lend to a reproducibility crisis, like in the fields of psychology, and like behavioral science, like a lot of the social sciences, I think see this a lot more often. But there's not a big crisis being talked about, at least in my field. That's the best that I can feel like I'm comfortable stating.
All right, so evolutionary biology is good to go with no flaws and no problems. You heard it here first, folks.
Gosh, I didn't say that, but it's yeah. I don't know. Again, I think it's a thing that's definitely been emerging in a lot of the social sciences, and so maybe something to follow for sure.
All right, so here at the end, just real quick for people who skipped the last hour and 15 minutes, here's what you should do. First, to see is the journal is it reputable? Does it have one word as its name? Then definitely good. It's kind of
Science
share.
makes a sell. You're good.
Yeah, exactly. Impact factor is useful if it's high. If it's not, look into why it might be. Does the expertise of the paper, or does the subject of the paper match the expertise of the journal? Mm-hmm. So if someone is publishing in a journal that is not related to the subject in which they're publishing, then that would be a huge red flag. Yeah. Look at the authors. You mentioned that trick that you mentioned where the first person is the grad student who did all the work and the last person in the lab. I didn't know that. So yeah, that's good to know. Yeah, I'd always kind of wondered, like, is there a fight over the order? Because like the first two people, their name is the one that people are cited with, right?
Yeah.
Like that guy. So like, is that like a thing that people fight over? Or
so it can be. I've never had a fight over it. Very often it's pretty clear who leads the research. And the reason it's because the project is either being guided by the postdoc or the grad students in the lab, and it's like part of their thesis or it's what they were hired to do, right? So they are almost always the first author, and they probably did 80% of the work. And then you've got a bunch of other people that did little things, like maybe they helped with the stats, or these people helped with collecting, these people helped with maybe experimental design. Like you have and then eventually you get all the way to the very end, and that's who their boss is. That's the PI of the lab.
Gotcha. Okay, so that's on the journal. Then when it comes to the paper itself, the abstract is like the pitch to read the paper. So if you're citing a paper and you're citing only the abstract, you probably messed up.
Yeah. You definitely messed up. You should never just cite an abstract.
Yeah. Read the introduction. That'll give you the background of what how they understand the subject to date. Then read the results. That's what they think their paper shows. Mm-hmm. Discussion is more like speculative, so don't rely on that so much. And after you've got a good understanding of that, you can go back and try to read the paper and see what you can understand there.
Yeah.
And if you get completely lost, you can go to a good subreddit. You can go to a good YouTube channel, like Talk Pop Gen, for example, if you're doing evolutionary biology. Any one of the science friends would be good.
Yeah.
That link is in the description below. Yeah. Also, you can email the person who did the thing. Be polite. Do not email them your pet theories. Don't do that.
Yeah. Yeah. Please don't email pet theories. Just email questions and clarifying things, not
Yeah.
pet theories.
Yeah.
Don't give them your thoughts on their work.
Put your pet theories in the comment section of a applicable YouTube video.
Exactly.
Where they belong.
Yes. Or on a Reddit, like just not to
Right.
them personally. Yeah.
Okay. Did I miss anything that you think is super important in the summary?
No, I think that covers everything. Yeah. I know that like it's when you're coming into this and you're trying to read technical literature, it's already sort of a daunting thing, and then to also have this like added thing of like, oh my gosh, now there's also predatory journals, and there's some journals are better than others, and there's like it can be a really complicated, overwhelming thing for sure. But I think if you follow the basic rules that we've kind of talked about here, you'll be set 99% of the time.
Awesome. So again, Zach's channel is linked in the description below. So do check him out. He puts out great stuff. If you're interested in biology, biology always makes my eyes cross a little bit, but I've compensated for that by making friends with biologists, and so I've like outsourced my knowledge of biology.
We're just like, here, do biology.
Right. Though I have outsourced it exclusively to bald, white, bearded guys with glasses.
We're actually what biologists look like. We're all just bearded white guys with glasses.
This is what peak biology looks like.
Yeah. Oh, that's embarrassing.
Awesome. All right, guys. Make sure you do the YouTube stuff, like, comment, subscribe. You know how to do it. And coming up, I'm gonna keep doing more of this apologetics for babies thing. So trying to get away from doing 100% shroud of turn content, though I've got more of that coming up too. Anyway, you know how it goes. But do all that. Remember, you've always got reason to doubt.